Hi there, it's Richard from Intelligent Advisor IT Consulting with a little bit of a video to accompany the quite long article that just appeared on our website. The key focus for the website article is really all about how you approach Oracle Intelligent Advisor or Oracle Policy Modeling projects when there is JavaScript involved. And the difficulty is that quite often the people who work with the JavaScript are not Oracle Policy Modeling or Oracle Intelligent Advisor specialists, and the Oracle Policy Modeling and Oracle Intelligent Advisor people aren't necessarily JavaScript experts. And it underlines one of the key elements for success, I believe, in Oracle Intelligent Advisor projects in general, which is generalism. You need generalists. You need people who, of course, you need the subject matter experts who understand the rules, the regulations, the laws. Of course, you need programmers who can ultimately produce wonderful extensions if you need them, or user experience specialists who can optimize the layout of the screens. But what really makes an Oracle Intelligent Advisor project tick are the generalists, people who have a grasp of both sides of the coin, maybe who have been subject matter experts in the past, or have been technical people and who are now sitting with one foot on both sides of the fence. Because although they may not be the most effective in either domain, they are able to see the challenges in both, and probably at that point steer the developers or steer the SMEs to understand the constraints of each side. We all work together, we don't work in a bubble. Just because we want to have a scenario system where we can have 50 different variables doesn't mean that it's actually a good idea from a user experience perspective, nor is it particularly feasible from a technical perspective. You probably knew this already, but it's one thing that really bugs me is when I see projects that are essentially broken because there's been too much focus on developers who have no concept of what it is they're modeling, have no expertise in the domain, and it has to be said, often have no expertise whatsoever implementing JavaScript for Oracle Policy Modeling. They come at it as if it was just another JavaScript project, but it's not. It has its own set of constraints. It has its own set of requirements that if you don't know them and you end up working against them, you will create rubbish. You will create a bad solution. Anyway, that's sort of the thing that's been on my chest for a while because I keep coming up against it, and that's what my company does. We fix solutions that are broken, but I wish we could be more involved in not fixing things, but suggesting how things could be done. Anyway, so about this little scenario, the idea is very simple. This is not the finished project at all. This is a kind of demo version which I've created, which takes out all of the specifics from the customer, and I've chosen a different country and a different system to display to you today. So if I show you something that's Australian, that's enough for you to know that it's not Australian. I've deliberately made it as generic and as non-specific as possible because I don't want anyone to feel like I am pointing fingers, because I'm not. The idea is quite straightforward. You have one or more properties that you own, and each of them is of a particular category. So you could have, for example, commercial properties, residential properties where you're the owner, or it could be a vacant property, because that drives how things are calculated. Also, it could be in one or more suburb, and I've chosen some Australian suburbs at random because I found them on the internet, and it doesn't matter where they are because this is not about Australia. And most property systems in real life have an API where you can search for your address, or you can search for your legal property code to find out the current value of that property. Now there is an API which I could have used and which we did end up using, but for this demo I'm not going to use it. I'm going to use a value list of properties, which I also found on the internet in the same place where I found this stuff about suburbs, but this is not about Australia. And behind each of these is a land value. Okay, so you can think of these as, in technical terms, this is a parcel of land, and behind that land there is a value. For various reasons, mostly clarity and construction, the actual data surrounding these is not stored in OPM. I'm a great fan of decision service references. References being web-authored tables and other things that are stored directly on the hub and are pulled into your project using this thing called a reference. The reference allows us to store the reference data, such as defined levies, defined charges, but it could also be, the rate of inflation or the current value of the minimum wage, whatever it is. Store it somewhere, but don't store it here in OPM, because if you store it in a decision service, when it changes, this project doesn't need to be updated because this project is reading this at execution time. So it doesn't have to have a whole update cycle just because you changed a value in the decision service. So here in the hub, and this is just a simple example, you might have your reference or static data. Now I've put static data here, but it could equally be a table. So you could have multiple choices. This is the web authoring interface, and those of you who know the web authoring interface will know that nowadays it's really very sophisticated. You can do tables, objects, all sorts of things, and you can pass that back to OPM so that OPM reads the stuff at runtime. So that's why we have a reference here. In our data model, we have modeled it as the property because, as we said earlier, you could have more than one property. People can own more than one property, and that's fine. And we want to calculate the data for each property. So we have a lot of property level attributes. And you'll see that we have some of them that are things like the number of recycling bins or the number of general waste bins. And then we have some that have a prefix of scenario. So scenario percentage increase, or scenario general rate, or scenario recycling waste charge. So we have two sets of figures. We have the real figures and then we have the scenario figures. The calculations are pretty much the same. It's number of bins multiplied by price per bin to get you the total cost of your bins. But the point is, by having two sets means we can use the real current rules to create the real answer, and then we can let the user play with the numbers to create the scenario and say, well, what happens if the price of a bin goes up by 20%? How will that affect me? And they'll be able to do that because we have two sets of attributes here in the property. The rules themselves are really as straightforward as I just mentioned. So, the green waste charge is the number of green waste bins multiplied by the charge per bin. So, this is just a very simple scenario example of what you can do. I'm not showing you the real deal, but I think it's going to be fairly obvious why this is of interest to us. Over on the interview, we've broken it down, and originally it had about 25 different screens. Now we have 4. About you, which is collecting the key data, like who are you a pensioner, so are you over the age of retirement, how many properties you have, and if you have at least one property, where is it and how much is it worth? And we're going to be calculating the value from a list of reference data to say that if your property is in this suburb and it has this number, then its property number 3 is worth £73,000 or 73,000 euros, or in this example, 73,000 Australian dollars. Then we're going to ask you some questions just for the fun of it, of course, because in real life, most of this information is probably publicly available, or at least some of it is what about levies? So in some countries, you pay extra money. If you live, for example, in the countryside, you pay a levy so that there's a volunteer fire brigade or there's a volunteer civil defense unit. So you're basically subsidizing the emergency services. Likewise, in many countries, you pay to have your waste collected. And some places you don't have that service because it's too rural, it's too far away, or quite simply it's just not offered in the street that you live. And finally, how many bins you have. Shouldn't be too difficult. The real core of this is this page. And again, this is not the final one. This is the ugly, designed by Richard one, but it shows the principle. I want you to notice 3 things. Number 1, you have numbers that are in red and numbers that are in black. Numbers that are in black are the real numbers. Numbers in red are the scenarios. Underneath you have sliders. Again, these sliders, in my experience, or something like a slider, is a great way of allowing the user to play with the numbers without asking them to write in physical numbers, because that takes ages. So you can go up and down and say more bins, more price, less price, and see the answers in the red boxes. Similarly, at the top, we might say to the user, well, look, tell us, what should we highlight for you? And the user says, well, if you go to 20%, that's a deal breaker. Okay, so what we'll do is we'll think about how we could make it obvious for the end user when the numbers exceed 20%, so 1.2 times the current value. So each user might be different. The user says, well, I don't really care if it's a 5% increase, but if it reaches 10%, goddammit, I want you to show me in big flashing letters that there's a problem. Fine. And this is, you can see where this is going. This is not just for simulating or scenarioing property charges, but this is also very good for when you've got multiple criteria. The user is trying to reach a balance and says, well, tell me when I reach a number that's between X and Y, and don't go above Z. So these are all very useful. What's down here, of course, is the custom component. So the custom control in this case is a container, and it's a container that is going to be displaying something really ugly, but at least shows the principle. In this case, for the demo, it's using D3, so one of the most common charting engines in JavaScript, and it's going to create one chart per property. We could have done it as one single chart, but for this demo, I've done it as one chart per property, and we're going to show the real value and the scenario value, and we're going to let the user understand what the differences are. So let's go ahead and play with this a little bit. So I took the opportunity to fill in all the details before I started, because it's a pain in the neck otherwise. And you can see I have my two charts. So the two charts, as you've probably guessed, are reading data from up here. Obviously, this data is just here for demonstration purposes. So at the moment, the rates values are the same because the scenario and real life are the same. And the costs of recycling, green bins, what have you, they're all the same. So the idea is really simple. Down here we have property 1 and property 2. We have in blue the current and true value as of today, and in orange the scenario value. Same for property 2. At the moment, everything is identical because we haven't played with any variables. Let's focus on property 1 for a second. Let's imagine that property 1, the land prices go down by 10%. So that means that their rates would go down, and that would be the rate that they would pay. If their land value goes up, they would see that they're paying more in rates. Similarly for property 2, if the land value suddenly spikes, their rates would go up, and they can see the differences here. If the rates really go up and hit a threshold that the user has defined, such as 20%, then we want to make it really obvious that they've hit whatever it is that they're worried about. 40% rates increase would be pretty rough. The key here is we're not doing any calculations in the JavaScript at all. Everything, right down to the is it over the 20% mark or not, the watermark that we're setting here, is all defined and calculated in Oracle Intelligent Advisor, Oracle Policy Modeling, in standard rules. You can see here, or maybe you can't, the high cost flag is active if you go over the scenario ceiling. So if the user sets a ceiling of 20% and your total scenario value is greater than the old value multiplied by the ceiling, in this case 20%, so 1.2 times the original value, then the flag is set. And the flag is passed as the output. Without going into any details, that means that in our code we can focus on simply revolving around the new value or the high cost. We don't have to do anything, or the original value. We don't have to do anything at all other than use JavaScript for what it was supposed to be used for in the extension, namely displaying the chart. Well, I hope this has been of interest to you, and if you have any questions, reach out to me. And if you're concerned that your project may be is imbalanced in how it views subject matter experts or JavaScript experts, or you have a concern about a use of an extension, or you just want to talk about your project in confidentiality, drop me a line on LinkedIn or elsewhere. Bye-bye.